All right, so the next test is the alternating series test. And this is actually a fairly reasonable test to implement. So this is number 8. What do I mean by alternating series? Okay, so alternating series is one that changes sign. All right, so it changes sign from positive to negative to positive to negative. So an example of an alternating series would be like the summation n equal 1 to infinity minus 1 to the n over n. Let's say n plus 1. So this might be 1 minus a half plus a third minus a fourth. Okay, that's alternating, or the summation, or the summation n equal 1 to infinity of minus 1 to the n over 2 to the n n minus 1 minus 1. So that might be 1 minus a half plus a fourth minus an eighth, etc. So these are alternating series. So alternating series are of the form summation n equals 1 to infinity of minus 1 to n plus 1 times some un. Okay, so in this particular one here, un is 1 over n. And in this one, un is 1 over 2 to the n minus 1. Okay, so alternating series look like such. All right, so here's the alternating series test. All right, so the series summation n equals 1 to infinity of minus 1 to the n plus 1 un converges. So this actually looks like u1 minus u2 plus u3 minus u4 ... This thing converges, and there are 3 conditions that must be satisfied. And you have to show all 3. The first one is all the UNs are positive. So UN is greater than 0 for all n. That's the first one. Okay, all positive. The second one is it has to be a decreasing sequence. So that means UN has to be bigger than or equal to UN plus 1 for all n after a particular value. So the tail end is decreasing. And the third piece is you must show that the limit as n approaches infinity of UN is 0. So if you can show all those 3 things, then a series is alternating series converges. So here's an example. The summation, make this the first example. There will be more. N equals 1 to infinity of -1 to the n plus 1 over n. Now that kind of looks like the harmonic series, but it is not. Here, un is 1 over n. So let's look at this. So first thing we get, so the first piece of the test A is that un equal to 1 over n is greater than 0 for all n greater than or equal to 1. Don't have to worry about that one. B, so un, which is equal to 1 over n, is bigger than 1 over n plus 1, which is equal to un plus 1. So therefore un is bigger. So therefore un is bigger than un plus 1. So that one is easy. And then C, the limit as n approaches infinity of un is equal to the limit as n approaches infinity of 1 over n, and that is 0. So by the alternating series test, summation n equals 1 to infinity of -1 to the n plus 1 over n converges. Okay, that's all we have time for today. We are not meeting tomorrow. The university is closed. The university is also closed on Thursday and Friday, and will be open bright and early Monday morning for us to get back to this work. So I will see you guys on Monday. Have a blessed Thanksgiving.
Professor,
Yes,
can you fix my attendance, please?
I can.
Thank you.